For this circuit, the only information we have is the value of V0, which is this voltage across these two parallel resistances, 40 ohms and 10 ohms there. So V0 is given as 5 volts. We need to find what is the value of Vg here. So if we start from this side, there we can see there are two current dependent current sources, this one and this one. The value of this one is 40 I2, and this is the control current I2, and this one's value is 25 I1. The control current is here I1. So we will start from here, V0. If we apply current divider rule, let's say we are finding the voltage drop V0 will be of course the current through I times the current through, let's say this one, 40 ohms resistance. So that times 40 either, or the current through 10 volts 10 ampere 10 ohms resistance times the 10 ohms. So whatever, I will do the 40 ohms one maybe. So this is the current, applying current divider rule. 40 I2 is the total current, and the sum of the resistances is 10 40 plus 10 times, since I am trying to find the current through 40 ohms, so I will multiply by 10. So this is the current through the 40 ohms resistance, and since I am trying to find the voltage, I have to multiply by 40. So that is the expression there. So this is 40 I2, and this will be 50 times 10 times 40. So basically this is gone there, and then this is 8 here. So we have 320 I2, and V0 is given as 5, so we have I2 5 over 320. Now let's this voltage is V1. Let's find what is the value of V1. V1 is voltage across this one or this one. Let's do the 81, so that will be 80 times I2. Since we know I2 now, and I2 is this current, so we will use that one. So we will use the current through the resistance 80 ohms. So that is our 5 here over 320 times 80 times I2, that is V1. So that will be 5 over 4 I2. Sorry, there is no I2 here, just this is I2, so I2 will be gone. Instead of I2, I actually wrote this one, which is 5 over 320. So 5 over 4 is the value of V1, 5 over 4 volts. So that's there. So now we have the value of V1. So we will express V1 in terms of I1, which is this current. So if we write V1, which is the voltage drop across the 80 ohms resistance, let's say the current here is 25 I1. This is being divided between these two resistances, 80 and 20. So if I want to find the current, 25 I1, the total resistance is, so I am applying current divider rule, 20 plus 80 times 20, since I am finding the current through the 80 ohms resistance. So this is V1, and then times 80 here, because the times the resistance, value of resistance. So we have 25 I1 here, this is 100, and times 20 times 80, so this is gone there, these two zeros, so that is 16, so that's 400 I1 is V1, and we know V1 is 5 by 4, so we can find I1 from here. So that will be 5 over 4 times 400, that is the value of I1. Let's leave it like that, we don't want to, or we can do that actually. So this one will be, so I'm leaving that, it's actually 80 here, so 1 over 320, so that's the value of I1. So we need to find Vg. If we go to the first part of the circuit, this one, Vg is of course I1, the total current, times the sum of this resistance. So that is like that, I1 times, here we have two resistances, which is 60 plus 260. 60 plus 260 is the sum of two resistance, because it's the total drop. That's what Vg is. So I1 is 1 over 320, 1 over 320, and 60 plus 260 is also 320. So we have these two cancelled and we have 1 volt as the result of Vg. So that's what we get from here.